World War II was a terrible global conflict. Nations battled fiercely on land, sea, and air. But there was another kind of battle. This was a secret war of minds. It was a war fought with codes and ciphers. Germany had a clever way to do this. They used a machine called Enigma. The Enigma machine created very strong codes. These codes protected Germany's secret communications. The Allies, like Britain and America, faced a huge problem. They could not understand these German messages. They needed to crack the Enigma code. It was a matter of victory or defeat. Breaking the Enigma code was a top priority. The German military believed Enigma was unbreakable. Its design was very complex. The daily settings changed constantly, but the Allies gathered their best thinkers. These people became secret warriors. They fought with brains, not bullets. The success of these codebreakers had a huge impact. It helped to shorten the war. This tale is about that secret battle. A simple look at encryption. Encryption is a way to make messages secret. Think of it like a secret language. Only people who know the secret can understand. You write a message, then you encrypt it. This means you change it into a secret form. Someone who sees the encrypted message cannot read it. It looks like nonsense. But if you have the key, you can decrypt it. You can turn it back into the original message. We use encryption in our lives every day. When you use a cash machine, your PIN is encrypted. This keeps your bank details safe. When you shop online, your payment information is encrypted. This protects it from thieves. Email programs can encrypt messages. This ensures only the receiver can read them. Encryption helps keep our digital world secure. There are many ways to create secret codes. Some are very simple. A substitution cipher replaces each letter with another letter. A transposition cipher mixes up the letters in a message. The Enigma machine used very complex versions of these ideas. In wartime, secret codes are vital. The Enigma machine looked a bit like a typewriter. It was portable, often packed in a wooden box. It had a keyboard for typing messages. It also had a lamp board. This was a panel of letters that would light up. Inside, it had a series of rotors or wheels. These rotors were the heart of the machine. They did the scrambling of the letters. There was also a plug board at the front. This added another layer of complexity. When an operator typed a letter, an electrical signal passed through the machine. It went through the plug board first, then it went through the rotors. Each rotor turned after a key was pressed. This changed the electrical path for the next letter. Finally, a different letter would light up on the lamp board. This lit-up letter was the coded version. The operator would write down each coded letter. This formed the secret message. What made Enigma so strong was its complexity. The number of possible combinations was enormous. Section 4. The Codebreakers, Heroes of Bletchley Park. The British government knew they had to break Enigma. They set up a secret operation. It was located at a country house called Bletchley Park. This place became the centre for British code-breaking. They recruited many brilliant people. There were mathematicians and linguists, chess champions and crossword puzzle experts also joined. These diverse talents worked together. Their single mission was to defeat Enigma. They worked in complete secrecy. Alan Turing was a key figure at Bletchley Park. He was a mathematical genius. He had new ideas about logic and machines. Turing quickly understood the Enigma machine. He realized how it might be beaten. He thought that a machine could help fight the Enigma machine. His theoretical work was crucial. He designed a method to speed up the search for Enigma's daily keys. Based on Turing's ideas, a machine was built. It was called the Bomber. The Bomber was not a thinking machine. It was an electromechanical device. The Bomber machines dramatically reduced the search time. They were essential to breaking Enigma regularly. Section 5. Enigmas echo a lasting legacy in technology. Cracking the Enigma code had a massive impact on World War II. The intelligence gained was called Ultra. Ultra gave the Allies vital information. It helped them know German U-boat locations. This was crucial in the Battle of the Atlantic. It also helped in planning major operations like D-Day. Historians believe that breaking Enigma shortened the war. It may have saved millions of lives. The work done at Bletchley Park was also a beginning. The machines built to break codes were early forms of computers. The Bomber, for example, performed logical tasks automatically. Alan Turing's ideas about computation were revolutionary. He imagined machines that could solve many different problems. This thinking laid the groundwork for modern digital computers. The need to break Enigma pushed technology forward. It accelerated the birth of the computer age. Turing's work also touched on artificial intelligence. He proposed something called the Turing test. The story of Enigma teaches us about the power of human ingenuity. The legacy of Bletchley Park continues.